This is the ME 2110 planning report for Team Dodge This, consisting of myself, Annie Thornburg, Cody Dawson, Ricardo Carbonell, and Ryan Thomas. In this presentation, we will review the objectives of the project, the planning tools used, and provide a brief conclusion of our results. The objectives of our machine are to score points. Points are scored through moving the Sentinel, the rubber bone, collecting programming modules, the tennis balls, depositing pills, ping pong balls, and rescuing Morpheus, the doll.
The most important customer requirements from the house quality include running autonomously, meeting size constraint, and attaining a high score. All these have an importance rating of 10, which is the maximum. Running autonomously and meeting size constraint are very important because if these requirements aren't satisfied, it will result in a DQ, and this machine won't be able to score points. Obtaining a high score is also important because the device will perform better in the competition, which is the goal. The engineering requirements that are the most important are average score, task completion, and disqualification rate. All of these have strong relationships with the most important customer requirements, which are high score, consistent performance, and autonomous function.
The objective of the machine is to score points. The function tree identifies the four methods of potentially scoring points. First, the machine must move the rubber object, which is done so by moving to the rubber object and then removing it from the zone. The second manner of scoring points is retrieving the doll, which is accomplished by extending to the center, sensing the barrier that surrounds it, and then retrieving it once the barrier has been removed. Similarly, points are scored by depositing ping pong balls in the center of the competition area. This is completed in the same fashion as retrieving the doll, but rather than retrieving the doll, ping pong balls are placed in the designated area. Lastly, points can be scored by extending to the tennis balls and then pulling them into the team zone.
The specification sheet was critical to establish target values in important areas such as geometry, energy, safety, and quality control. Some key engineering requirements outlined in the specification sheet are 2 foot by 1.5 foot by 1 foot volume constraint found under geometry, less than 1% software failures found under quality control, and 100% autonomy found under ergonomics. Other, almost equally important specifications include less than 30-second reset time and 75% recyclable. The design team is responsible for satisfying all specifications, but should primarily focus on those that are listed as demanded.
The morphological chart provides a visual representation of the sub-functions discussed in the function tree. Many of the same solutions are proposed for different sub-functions of this machine, such as solutions for sensing the barrier, for retrieving the rubber doll Morpheus, and for sensing designated area for placing the ping pong balls. Some of the more popular solutions you can see by the repetition of the solution for different sub-functions. Some of these include the use of extendable arms, such as pushing the object forward or pulling an object inward and removing the rubber object Morpheus, or such as the use of switches for sensing barriers or designated areas. A solution then can be chosen straight from the morphological chart, considering materials we have on hand, space available in the machine, or even trial and error for what works best. Prioritization matrix contains a list of the most important tasks involved in creating the final design project. The 7 tasks were then related to each other with a percent of relative importance and comparative to all other tasks. From this comparison, we were able to determine that create preliminary designs and plan for building stages were the 2 most important tasks. These 2 tasks were rated as most important because in comparison to all the other tasks, they are the most involved with building a machine that will score an overall highest number of points.
The tree diagram breaks the design process into 6 main objectives, including problem understanding, conceptualizing design, making prototypes, finalizing design, and assessing the process. This gives a better idea of how much time needs to be spent where. Problem understanding includes house of quality, function tree, and spec sheet. They won't take a lot of time, but it is important that they are made well because these tools will be referred back to for the entire project. Producing prototypes will consume a lot of time because they encompass coming up with, combining, and evaluating mechanisms. These steps will involve building, testing, and tearing down, which will really be the heart of the design process.
The Gantt chart describes when work on a specific task should begin and end for the overall project. Scheduling within the chart is set up so that any dependent portions of the overall project occur after the tasks that they depend on are completed. Additionally, tasks that are somewhat related overlap in the Gantt chart. For example, the last week of problem understanding overlaps with the first week of robot design/construction. This is because preliminary designs and construction often take place while the overall problem is still being understood, so time is allotted for these objectives to occur at the same time.
A job responsibility matrix was used to divide the final project into individual jobs and distribute them amongst the members of the group. All category-oriented jobs were assigned as the primary task of Ricardo. Cody would serve as a secondary help in order to assure the best possible design. Building the actual mechanism was assigned as Cody's primary responsibility. On the other hand, Ryan is in charge of writing the necessary code to have the machine perform the given tasks. Finally, Annie has the primary responsibility of putting up all the required reports and presentations.